In this lesson, we're looking at Chapter 16, Section 5, and we've already learned what a matrix is, plural is matrices. We are still pursuing Algebra 2 Standard 2.0, which we did most of it earlier in the year, but in this case we're learning how to solve systems of simultaneous equations using matrices. To do that, that brings us to today's objective. Today's objective is to find the determinant of a 2 by 2 or a 3 by 3 matrix. In the previous lesson, we discussed that a square matrix, we can do things to it that we cannot do to matrices that are not square. Square matrix, you recall, is one that has the same number of rows as it does columns. So we have a 2 by 2 matrix and a 3 by 3 matrix. Today we're going to find the determinant. We start by saying that every square matrix has a real number associated with it called its determinant. And if we're using capital letters to name the matrix, we have a matrix capital A, these two notations are notations that we use to find the determinant of A. I know they look like absolute value signs, but instead of having brackets at the top, this is one way of saying find the determinant of A. And here's another way we abbreviate the first three letters of the word determinant and find the determinant of A. Now what we do, the number of elements in any row or column, since these are the same, are called the order of the determinant. So when we're looking for a 2 by 2 matrix, it's a matrix of order 2. So here we have the matrix. We'll just do this in general so we can supply numbers later. It's matrix A, B, C, D. And you can see in the matrix notation we put the square brackets. And when we want the determinant, we take off the little square part of the brackets. And yes, it does look like giant absolute value signs, but it's not. It means find the determinant of matrix A, B, C, and D. Okay, and then two notations again. We'll write DET for determinant of A, or we'll put that symbol around it, meaning find the determinant of matrix A as well. All right, let's do the formula for how we find the determinant of a matrix, a 2 by 2 or order 2 matrix. What we have here is that it's matrix A, B, C, D. We want to find its determinant. The way we do that is we multiply the diagonals going down from left to right. So the elements in this matrix are A and D in the diagonal going down, so we multiply A times D. Then we subtract the product of the diagonal going up from left to right. In this case, that's the product of C times B. We subtract that. When we simplify that, that'll give us the determinant of our 2 by 2 matrix. So let's look at a numerical example and see what happens. So the matrix is 7, negative 3, negative 4, 8. We'll multiply the diagonal going down. 7 times negative 8. I know you can multiply that in your head, but I'm just going to write out the steps here. So that's 7 times negative 8. And we're subtracting the product of the diagonal going up, which is negative 4 times negative 3. If we simplify that, we'll have our determinant. So 7 times negative 8 is negative 56. Negative 4 times negative 3 is a positive 12. And we're subtracting. So negative 56 minus 12 gives us our determinant of negative 68. And that's finding the determinant of a 2 by 2 matrix using what's called the definition. Now that was fairly simple, so let's move on to find the determinant of a 3 by 3 matrix using its definition. And its definition is as follows. Now, we don't expect you to memorize these letters of the alphabet and in the order, but there's a pattern here that we'll see as we look through a numerical example. Essentially, to find the determinant, we're going to multiply all the diagonals going down from left to right that contain 3. So we have A times E times I. Now, as you look at this, you say, well, where are the rest of them that go down from left to right? Well, let's make this a two-step process here. And then we will find some diagonals containing 3 going down from left to right. So what we want to do is we want to take this 3 by 3 matrix and we want to copy over the first 2 columns in the matrix again after the matrix. So here's our matrix A, B, C, D, E, F, G, H, I. We're going to take the first column, A, D, G, and write it over again right outside behind the matrix. We're going to take the second column, B, E, H, and write that behind the previous first column. So now as we look at this, we'll be able to see that we have diagonals containing 3 numbers. What we'd like to do is we want to multiply all the diagonals going down from left to right that contain 3, and we're going to add those results together. So let's do that. If we multiply going down, we can see here that we have A times E times I. Then multiplying diagonal containing 3 going down, we have B times F times G. And then this next diagonal going down, we have C times D times H. So again, all the diagonals going down from left to right containing 3 elements, we multiply those numbers together and we find their sum. Now we're not done yet. The next thing we need to do in this process is to find all the diagonals going up from left to right, find their product, and subtract those results. So again, let's take a look at the subtraction process and then we'll put all things together. So the diagonals going up from left to right, we have G times E times C. So we're subtracting a G times E times C. We're going to subtract an H times F times A. So we're subtracting the H times F times A. And we're going to subtract I times D times B. So there's our subtracting I times D times B. Now, it's important that we know this is called finding the determinant of the matrix by using its definition. This only works, as we've mentioned previously, here for a 2 by 2 matrix and now here for a 3 by 3 matrix. And so that's how we've got the AEI plus BFG plus CDH minus GEC minus HFA minus IDB in the definition that we showed a little bit higher. So let's scroll back up to that so we can see that's where we got that information from. There's the AEI plus BFG plus CDH, and then we're subtracting the GEC minus HFA minus IDB. So again, I recommend we don't necessarily memorize the letters, but maybe we would memorize the process. So multiply all the diagonals going down from left to right, add the results together, and then multiply all the diagonals going up from left to right and subtract all those results. Let's look at a numerical example. So we're going to find the determinant of this matrix. So let me scroll up so that we have room for it. Let's write the first 2 columns over again. So I've got the column -1, -5, and 4. We're going to write behind it. And the second column 0, 1, and 8. So let's start with the process of multiplying all the diagonals going down from left to right. So -1 times 1 times 1. Again, diagonals going down. We are going to add the results. So I'm going to add to that the product of the next diagonal. 0 times -1 times 4. Now I know we know that's 0, but I'm just going to write it out for now. 0 times -1 times 4. And then plus the product of the next diagonal going down from left to right. 1 times -5 times 8. So there's the plus 1 times -5 times 8. Alright, we've taken the product of all the diagonals going down from left to right that contain 3 numbers. We've added those results together. Now let's go up, find all the diagonals going up from left to right that contain 3 elements. Multiply those numbers together and subtract them. So we're going to subtract 4 times 1 times 1. We're going to next subtract 8 times -1 times -1. So there's our subtraction of 8 times -1 times -1. The next diagonal going up that contains 3 numbers is we're going to subtract 1 times -5 times 0. So subtracting 1 times -5 times 0. So if we simplify that, we'll get our determinant. So let's continue to do so. Let's continue to work on this. So -1 times positive 1 times positive 1 is negative 1. 0 times anything is 0. 1 times negative 5 times 8 is negative 40. And let's work on our subtractions here in red. We're subtracting 4 times 1 times 1, so that's subtracting 4. We're going to subtract 8 times negative 1 times negative 1, so that's subtracting 8. And then we're subtracting 1 times negative 5 times 0, and 0 times anything is 0. So if we continue with that, let's simplify. Negative 1 plus negative 40 is negative 41. I was combining the numbers in blue here. Combining the numbers in red, negative 4 plus negative 8 is negative 12. And when we finish that off, negative 41 minus 12 is negative 53. And we've just found the determinant of a 3 by 3 matrix. Alright, well, let's find another one. Always good to practice. So here's our next 3 by 3 matrix that we want to find the determinant of, because we don't have the square brackets around it. So let's rewrite those first two columns again. Negative 3, 1, negative 1 outside the matrix, and 3, negative 6, 0. And let's go through that process again, finding all the diagonals going down from left to right and adding those results together. So negative 3 times negative 6 times negative 3, we're going to add that to our next diagonal going down. We're adding the next one, which it is 3 times 1 times negative 1. We're going to add the next diagonal from left to right, so we're adding 0 times 1 times 0. Alright, it's time to do the subtracting of the diagonals going up from left to right. Doing that, we are going to start by subtracting negative 1 times negative 6 times 0. We're going to subtract the next diagonal going up from left to right, so that's 0 times 1 times negative 3. We're going to subtract again the next diagonal going up from left to right, so we're subtracting negative 3 times 1 times positive 3. If we simplify all of those numbers, we'll have our determinant, so let's go through and do that. Negative 3 times negative 6 times negative 3 in the blue is negative 54. Our next term, 3 times 1 times negative 1, that's adding a negative 3, which is the same as subtracting a 3. Adding our next term here, we've got 0 times anything, of course, is 0. It's time to do our subtracting in the red. And there's a 0 there, so 0 times anything is 0. Our next subtraction has a 0, so 0 times anything is 0. And then we're subtracting negative 3 times 1 times 3, which is subtracting a negative 9. Don't forget that it's subtracting our negatives or adding positives. Negative 54 minus 3 is negative 57 to combine our blue numbers. And minus 0 plus 9 is positive 9. And then negative 57 plus 9 is negative 48. And that's the determinant of this 3 by 3 matrix. So we've done a couple examples of that. We found the determinant of a 2 by 2 matrix and the determinant of 2 of the 3 by 3 matrices. And this process again is called finding the determinant using its definition. Now, by the way, just a little forethought as we look ahead for their next chapter test, chapter 16. Again, you are not allowed to use any TI 80 or 90 series calculators on this test. The 81s, 82s, 83s, any of the 90s, because they have ways to find the determinants of matrices without you having to do the work. So again, that's today's objective, to find the determinant of a 2 by 2 matrix, to find the determinant of a 3 by 3 matrix using the definition.